Hello again. I will continue with the last talk. The last talk we were talking about the three types of radiation. The first radiation is the radioactivity was discovered in 1886 by Becquerel. There are three types of radiation called alpha, beta, and gamma rays. The first type of radiation is called alpha. Radiation of alpha particles. It occurs when we emit alpha particles. Is when one initial nucleus emit a nucleus of helium and emit another nucleus with without two protons and without two neutrons. This is the alpha. And beta, there are three types of beta radiation. The beta minus is when one initial nucleus inside the nucleus one proton, okay, let me write here, one neutron will transform to a proton, okay, and will emit a electron and positron, and an antineutrino of electron. The second process that concerns to beta decay is the beta plus, that the proton transform to a neutron plus a positron plus neutrino of electron. And the next process is when one proton plus one electron transforms to one neutron and emit neutrino of electron. Okay, let me remind that the value of always the mass of the neutron always is greater than the mass of the proton. So this process, the beta plus process, okay, on this process only occurs when occurs only inside the nucleus. I mean, if you have a single neutron, the neutron never if we have only one neutron, okay, the neutron could transfer to a proton without any kind of problems, because the mass of the neutron always is greater than the mass of the proton. But if we have the opposite case, when one proton transform to a neutron, this only happens inside the nucleus, never when the proton is alone. A single proton never will transform to a neutron by itself, because this process doesn't satisfy this okay, due to this inequality, this process is forbidden if there are only the single proton. But if we have inside the nucleus, this process is allowed. So now let's continue with the process of gamma. The gamma decay is very easy to explain. It's when you have a charged nucleus. Let me, for example, let me, how can I explain? Okay. If you have the gamma decay, okay, occurs when you have one initial nucleus and this nucleus is excited. Therefore, in order to disexcite the nucleus, this nucleus remain the same. Okay, but now it's not excited and will emit a photon with this magnitude of energy, that is the constant of Planck multiplied by the frequency. Okay, so this was the last decay that I had to explain. Thank you.